Hi, everyone. My name is Netta. I am a senior front-end developer at Tikal. And before I start, I have a very important question to all of you. Has everyone already had at least one beer? Okay, so about half of you are in the right state of mind to talk about functional reactive programming in RxJS. Half of you should have had that beer already. Okay, another show of hands. How many people in this room feel very comfortable with RxJS? Okay, we're in for a ride today. What I want to talk about is functional reactive programming. I do want to give a heads up and an apology. My computer is actually not connected. I am sharing my screen with a computer over there, so there's a bit of a lag. Sorry for that, but it should be pretty smooth sailing, hopefully. Okay, so functional reactive programming, or FRP for short, has become a bit of a buzzword. I've heard it thrown around a lot recently. And if you go online, like I did, and try and find resources about this, chances are you'll see stuff that looks like this. This is from the official RX website. Now, you can definitely say it's complicated, and that is maybe one issue here, but the larger issue to me is that a lot of the resources we have are very, very focused on implementation, and they don't necessarily provide a lot of insight into functional reactive programming as a paradigm. And so what I want to do today is I want to use this demo app that I've built, and I want to talk, we're going to look at code, and we're going to look at implementation and how you do things, but I also want to talk about how you think about things in an FRP world, or in the FRP paradigm. So we're going to do this using a demo app, which is an app that I built. I have a bit of an ADD, so working with productivity timers like this really helps me focus, and that's why I decided to build one. Now, it's pretty straightforward in its capabilities. When you start work, you click the start button, and it'll start to count down. Then when it reaches 0, it'll give you a little alert saying, yay, done working, good job. If you want to take a break and go get a coffee, then you can pause it. And then, if you're me, eventually you realize your coffee break took too long and you haven't gotten any work done, and then you need to restart it. So you can also do that. There are some other things happening here. You've seen the background image change, and we're not going to be talking about all of that, but I will give you a link to the repo so you guys can check it out later and see what's going on here. What I want to talk about specifically today is the start and pause mechanism of the timer, because it turns out that there are some interesting things happening there in terms of FRP. So if you've seen Michel's talk earlier today, you would have seen that he gave a definition of reactive programming, which I think was quite accurate, but I don't remember it right now. But what's important for me to say is that it's a good definition and you should go look at it. I'm not going to define functional reactive programming. What I want to talk about is the building blocks of this paradigm, which are streams and pure functions. So streams are a type that emits values over time. This means that a stream is characterized both by the kind of values it emits and by when it emits those values. In RxJS, they're called observables, and we can actually see one of these in the wild if we go looking at our code. So this is the actual code of the app, and I'm just going to comment out the timer functionality, if I can, if it lets me, good. And then I'm going to use this start stream here, this start observable, to show us all sorts of things. So start is a stream. I am creating it using the from event method that is a part of RxJS. And this means it creates a stream, in our case, from the click event on the start button. And we can actually see what's going on here by subscribing to it and logging the result. So now when we go back to our app and open up our console, we're going to be able to see what's happening inside the stream. Now when I click start, you see what's getting emitted from that from event function is a mouse event type. And in fact, when I click the button again, you'll see it's getting emitted again. And this is a kind of demonstration of what this stream actually is. So it's a stream that emits a mouse event type value, and it emits whenever the button is clicked. One type of stream that we'll be working with a lot today. Then if I look at the second building block of FRP, functional reactive programming, it is pure functions. Again, Michelle also mentioned this, but I'm just going to recap a little bit because pure functions are very important to us in FRP. So these are functions that have explicit inputs, explicit and consistent outputs. So that means they return the same output for the same input every time, and they have no side effects. So they don't change things outside of themselves. And the way we most often use pure functions in FRP is through operators. Operators is a fancy word for a pure function that takes a stream as an input and returns a new stream as an output. And again, we can look at one of these in our code. Let's have a look at the very ubiquitous map operator. So now instead of just immediately subscribing to my stream, I want to pass it through the map operator. Now what map does in RxJS, it's very similar to map in vanilla JavaScript. It takes this input stream here. Oh, by the way, sorry, let me mention that this pipe method is a part of RxJS, if anybody was confused by it. And this is what allows us to pass this stream to this operator or operators here. So what map does is, for every value emitted on this input stream here, it's going to create a new value based on the function that we provided, and it's going to emit that new value in the output stream. So if I were to tell it to map these events to the number 1, then now, again, if I subscribe and log the result, we'll see an error, but when my app refreshes, it's going to be fine. Now when I click it, you see it's emitting the number 1. So what map actually did is it took the start stream that we saw before as an input, it applied the function to it, and it's created a new output stream, and this output stream now emits 1 whenever the button is clicked. So these are our 2 building blocks. And when we're working in FRP, the main question we're asking ourselves constantly is, how do I apply operators to streams in order to create the results I want? So this is the question we're going to keep asking ourselves today as we're looking through the code. Now there's one more thing we need to do before we get into actual FRP logic, which is we want to start by coding our inputs and outputs. And in fact, when I was writing this app, this is what I started from. So this is vanilla JavaScript. Our inputs include things like the start button and the pause button, and then our main output is the timer display. Now, the reason I wanted to start from this, there's 2 reasons actually. First of all is that input-output is by definition a side effect. And so when I'm working in FRP, I want to encapsulate it and sort of put it aside, not worry about it anymore, not touch it anymore, not deal with it when I'm writing my logic. This way I'm separating my side effects from my FRP world. And then the second reason I want to start with this is that identifying inputs and outputs early on is going to give me a really good foundation for structuring my app. And this is because streams always go from input to output. Now, when I say input here, I'm talking about any event that happens in our app. So we saw before clicks. It can also be user input, but it can also be server responses. So these are going to be the places where my streams originate. And then the outputs are the changes that I want to create, I as a developer want to create in my app. So usually that will mean changing the DOM. And when I start by identifying inputs and outputs like this, what I'm actually seeing are the places where my streams start and the places where I want them to end. And so now from that I can infer the answer to the question we asked before, which is, how do I apply my operators to my streams in order to create the result I want, in order to go from where I started to where I want to go. So let's have a look at one of these streams, and let's understand it first, and then we'll dive into code. This is the main stream in our app. It's the timer stream, and we're starting again by identifying inputs and outputs. So the input here is the click to the start button, and then the output is that timer display we saw before that is showing these strings of timey-wimey values. And so the first stream I see here is going to emit that mouse event, like we saw before. And then the last stream I see, or the last stream I want to see, is a stream that emits these strings every second. And so this means that I have to transform the two key characteristics of my stream. I have to transform when it emits, and I have to transform the value it emits. So I want to go from a stream that emits on the click to a stream that emits every second. And then I also want to go from this mouse event that we saw before, or mouse value, I want to calculate the value that represents how much time is left on my timer. So let's see this in code. And again, we're starting with this from event that we saw before. And we can create a stream that emits every second using this timer function. This is a part of RxJS. And what it does is, the second argument here is a duration. So it'll emit that often, in our case, 1,000 milliseconds or 1 second. And then the first argument to the function tells it when to start emitting. So I want it to start emitting immediately. That's why I'm passing in here 0. And what this is going to create is a stream that emits every second, starting immediately. So from event, we saw, and I think it makes a lot of sense for people working in the web and working with events. And then timer here, I also think makes quite a bit of sense. It's very similar to interval. But you can see here that they're being connected by this weirdly named operator called exhaust map. And not only is it weirdly named, but also the syntax here, if you've noticed, is a little bit different. Before, when we used pipe, we piped our stream to the map operator, but now we're piping it to exhaust map, and then inside of exhaust map, we're creating another stream. And this is because exhaust map is a higher order operator. So that means it helps us deal with streams of streams. Up until now, we've seen streams that emit values. So things like events, integers, strings, stuff like that. But streams can also emit other streams. And in fact, it's this capability that allows us to create complex behaviors in FRP. However, we need operators, special operators, to help us manage this case. And this is where higher order operators come in. So if all of that sounds a little bit hazy or too much in the air, that's fine. We have code, and we can look at what that means exactly. So now what I'm going to do is, I'm going to start off and just take this map operator that I used before, but now I want to use it to create my timer stream, and I just want to see what happens. So I'm going to pass it a slightly shorter duration, just so that it goes a bit faster. And now I want to see what happens when I click my start button. What's getting emitted here is not the timer, it's an observable. If I click it again, you'll see it again. What I've created is an observable that emits observables, so a stream of streams. And this is good. It's going to help me create the timer that I want, but this is not the result I want. What is actually going on here? Well, we saw map before, and map's behavior doesn't change. It's behaving in the same way. What it does is, it takes a value on the input stream, creates a new value, and then emits that value in the output stream. So what I'm telling it to do here is I'm telling it, for every event, create a timer observable, and then emit that timer observable. So that's what we're seeing here in the output stream. And what we want is we actually want to sort of dig one level deeper. We want to get the values from this inner observable and emit them in the output. Okay? And this is what higher order operators do. They get the values from the inner observable and emit them in the output. Let's have a look at a couple of these just so we can see kind of how they work. And I'm going to start with one that, the one that has sort of the most naive strategy for handling this, which is merge map. So I'm going to use merge map to create my timer now. And what merge map does is, for each value emitted on the input, it's going to create a new value on the output and emit that. Then when a new value comes in on the input, it's going to create a new value and emit a new observable and emit the values from that on the output. And it's just going to keep going like that. So if I'm applying it to my timer, now when I click start, first of all, this is good. I'm getting my timer, so I'm getting what I want. The values from that inner timer are getting emitted. But now when I click start again, you see it's created a new timer, and it's emitting both of those in the output. And if I click it again, it'll create a third timer, and so on and so forth, because for every value coming in on the input, it creates a new output, and it emits all of those. Now, if our timer was to somehow complete, then some of the timers would complete and some of the timers would keep going, but we haven't given it a completion condition. And so what's going to happen here is it's just going to pile on timers and keep on going. So not very useful for our case, can be useful for other cases. But we've already seen something that could be useful for us, which is the exhaust map operator. So if we already know that's useful, maybe let's have a look at that and see what it does. So the specific functionality of exhaust map is that for the first value coming in on the input, it'll create a new output. Then, so long as that output keeps going, it's going to ignore any values that are coming on the input. And what this does, in effect, is it allows us to disable the button once it's clicked. So now when I click start, my timer starts running like I want it to. If I click start again, and I'm clicking, I'm going to see if you can hear it. Can you hear it? No? Okay. Well, I am clicking. It's not doing anything. It's just ignoring any new values so long as this timer keeps going. Now, if this timer was to stop somehow, then okay, the next value on the input, the next click would create a new timer. But so long as it's going, any new value coming in is just getting ignored. So this is another way to handle streams of streams. And then there are others. For example, we could look at the switch map operator. Switch map, what it does is, for each new value emitted on the input, it's going to create a new output and switch to that output. So it'll stop emitting the old one and start emitting the new one. Let me just comment this one out so that we don't get weird behaviors here. So now when I click the start button, my timer is emitting. And then if I click it again, you see it's created a new timer, and it stopped emitting the old one, started emitting the new one, and if I keep going, every time I click, it's going to create a new timer and stop emitting the old one. So these are just 3 examples of higher order operators. There are more. But the important thing to remember about higher order operators is that they are our way of dealing with streams of streams. Now, it is possible that some of you out here are sitting and looking at me and thinking, what is she talking about? If that's the case, you are normal. Congratulations. Higher order operators are notoriously difficult to wrap your head around, and it really takes kind of digging into it and using them in order to sort of get a feel for how they work. So if this feels like too much, too fast, that's totally fine. Let's just put all of that to the side, and let's just take for now as a given that exhaust map in this case creates the type of behavior we want. Okay? Let's go from there and build our timer stream. So I'm using exhaust map. I'm creating this timer. We saw before what it does is emits these incrementing integers every second. And because it emits incrementing integers, I can use it to calculate how much time is left on my timer by subtracting those integers from the total number of seconds I have. So that's 1,500, the total number of seconds in 25 minutes. And I'm going to be subtracting these numbers so that each and every second I know exactly how much time is left. Now further on down the stream, I'm going to want to use map again to format these numbers into the strings I want to actually plug into the DOM. But for now, I'm going to leave it like this because I also want to be able to tell my stream when to stop. I want to tell it to stop when it reaches 0. And I can do that using the take while operator. And all this does is it tells my stream only emits values so long as they are larger than or equal to 0. Then when it reaches 0, it's going to complete and stop emitting any more values. And this is it. This is the timer stream. And this is the moment. So do you know this moment when you're coding an app, when you start to believe it's going to be okay? This is that moment because I have my timer stream, I have a grasp on higher order operators, so I'm feeling kind of good, happy, even maybe a little bit confident. And you know that's a lie, right? You know what's going to happen next. The next thing that happens is I think to myself, all I gotta do is implement the pause functionality. How hard could that be? Okay, guys, take a deep breath because the pause functionality has some interesting lessons to learn in FRP. Let's start by thinking about what it is we want to achieve here. So I have this stream already, this timer stream. It starts when start is clicked, and it's emitting these decrementing values. Now I want to somehow combine it with the pause click so that when pause is clicked, it stops. Turns out, this is not so straightforward in RxJS because most of the methods RxJS has for stopping a stream have to do with completing it. So we saw take while before, and there are others. These are all methods that complete the observable. And the problem with that is that once an observable completes, it can never emit any more values. So that's not good for me because for me, I want to be able to click start again and restart this stream, restart my timer. And so this is the moment when I know things are actually not going to be okay. And I have to go and take a very long break and sort of think about why I decided to do this and what in my life has led me to this point and made me such a disappointment. But after I do that for a little while and feel sorry for myself, I gather my strength and I get back to this and I look at it and I realize something. This behavior isn't about stopping anything at all. It is about switching between two different types of streams, the type that emits these numbers and the type that doesn't emit anything. Now, because I'm thinking about switching, that's already pointing me towards the switch map operator. Remember we saw in switch map, whenever a new value comes in on the input, it creates a new output and switches to that output. Well, if I can combine the start and pause click to both be my input, and then map the start to this timer stream, and map the pause to this empty stream, then I can use switch map to switch between them. And in fact, what we're seeing here is the power of streams, and the type of complex behaviors they allow us to create. Let's see it in code. So I'm going to be combining the start and pause streams, and so I want to start by mapping them each to a unique value so that when they're combined, it's easy for me to tell them apart. Then I'm going to combine them using the merge operator. Now, merge is a really central operator in all FRP systems because what it does is it takes as input multiple streams and returns as output a single stream that emits all of their values. And again, we can see this in our code quite easily. So now, instead of doing all of these experiments with the start stream, I'm just going to do exactly what is there in my presentation. I'm going to use map2 in order to map it to the number 1. And map2 is just an operator that maps to the same value every time. So I don't have to provide it with a function. I can provide it with just a value. So I'm mapping start to 1 and pause to 0. And then I'm going to merge them here. And then I want to subscribe to that and sort of see what's happening there. So I'm subscribed to the merge stream here. And now, when I click start, see it emits the number 1 as expected. And when I click pause, it emits the number 0. And of course, if I were to click them repeatedly, they would keep on emitting those numbers. But the important thing to understand here is that what is emitting those numbers is now a single stream. And I can use that stream as the input for my switch map in order to create my start and pause functionality. And I'm going to do that by mapping the number 1 to the countdown stream. So the countdown stream is the stream we saw before that we built together that is counting down from 1500. And then I'm going to map the number 0 to this never stream. Now this never is a constant that is a part of RxJS, and it creates a stream that never emits any values. And again, we can just keep going with our code and have a look at this behavior. I'm not going to recreate it exactly just because that would be a bit too much to look at, but I do want to show you what switch map does in this case. So I'm going to just, when I have a value or when 1 comes in, I would just want to create this timer that we saw before. And then if nothing comes in, I'm going to use my never const, and then I want to again subscribe to it and log the result. And so now, when I click start, it's starting my timer. And when I click pause, give it a few seconds to be sure, but my timer is actually paused. But the most important thing here is that if I want to restart my timer again, I can click start and it'll just keep going. So I can actually implement both of these behaviors, pause and then restart again. So this takes me a very long way forward. It allows me to create this start and pause behavior, but it also creates a problem for me, which you may have noticed already looking in the console. Now it's true that now in this example, we're only using a simple timer, but even if we were using my entire countdown stream, it's always starting from a timer. And that timer, when I start it, it's always starting from 0. So what I'm going to have here, since I'm using this value to calculate how much time is left, I'm going to see my display a timer that is restarting every time for 25, right? Because if I pause it and I start it again, it's starting from 0. So it's always going to start from that 1500, which represent 25 minutes. And so this is not very good for me. This is not what I want. What I want is the ability to keep track of where I was in my countdown when I clicked pause. So essentially, I need a mechanism for storing state. And state is a really interesting problem in FRP, because if you think about it, a stream only ever has a value at a specific moment in time. So how do I handle state in this situation? How can I sort of store, or save, or hold some value and then use it again in the future? Well, the easy solution to this problem would be, well, let's just save it to a variable and then we can read from that variable in the future. However, that would be a side effect, and that would be sort of violating this FRP world that I have built. So what I want instead is I want to create some mechanism for sampling this value, and then I want to somehow emit it again in the future when I want to be using it again. And in RxJS, I can do that using subjects. Subjects are both observers and observables. That means they can subscribe to streams and also emit values. And it's this behavior that is going to allow them to allow me to use them to store state. Now here is what I'm trying to achieve. This is my subject right here. And I want to create something like this. Whenever pause is clicked, I want to sample a value from the countdown stream, and then I want to sample it by my subject and sort of leave it alone. Then when start is clicked again, I want to be able to get that value and use it in order to keep calculating my timer. Now, what I'm creating here, and what looks maybe a little bit weird, is a circular dependency, because the value emitted by this subject is dependent on this stream. So this subject is dependent on this stream, and the stream is also dependent on this subject to keep on calculating its values whenever it's restarted. And it looks a little bit weird, but in FRP it makes sense because they're not going to depend on each other at the same time. And it's this ability that allows us to create these state loops. And in fact, this is something that we expect to see when we're working in FRP. Let's see what this looks like in code. So I'm going to start by creating my subject. What happens with the subject is that once it's subscribed to a stream, it will emit the same values that the stream emits. And this subject is going to be subscribed to this stream here. What this stream does is it emits the value from the countdown stream whenever pause is clicked. Okay, so whenever pause is clicked, it samples the countdown stream and emits that value. And so if my subject is subscribed to it, my subject is going to behave in the same way. Whenever pause is clicked, it's going to emit the latest value from the countdown stream. So this in itself is not enough, right? It's not enough yet. It's not yet solving my state problem, because now what I have is a subject that emits a value whenever pause is clicked. That's not useful. I need that value when start is clicked again. And I can get that, I can do that by using this with latest from operator. So with latest from returns the latest value emitted on my subject. And now I can use that to sort of know where I was in my countdown when I paused, and then keep on calculating from there. And in fact, with latest from emits two values. It emits the value from this subject here. It's also going to emit the value from this timer here. And so then I can again use map to calculate the difference between them to represent how much time I have left. Now the only thing I want to make sure when I'm do this is I want to make sure that my subject always has a value. If I reach this stream and my subject hasn't emitted anything, it's going to error. And so I want to change it to be a behavior subject, which is just a subject that is initialized with a value, in our case 1500. And so you see that from the get-go, from the first time that this countdown stream is started, I'm going to have the correct value here to calculate how much time I have left. And that's it. That is the pause mechanism. And while building this, we've seen some interesting concepts in FRP. So things like streams of streams and higher order operators and switching and state loops. And now, since you know I can read your mind so well, I know what you're thinking right now, and that is, wow, FRP is so simple. In fact, Gil Tayar, who is sitting right here, didn't know I was going to point him out, but he asked me a while back if RxJS wasn't just over-engineering. I said no, surprisingly. If I hadn't said no, I probably wouldn't be here today. Maybe I'd be under a blanket somewhere crying. But no, I honestly don't think it's over-engineering. I think what it is it's a different paradigm. And as such, it is challenging to some very deep-rooted notions we have about what programming is. And that's what makes it so hard. It's hard to have to rethink very deep-rooted ideas. Sometimes we don't even know we have them. But I do think FRP is an incredibly relevant paradigm for the web, because what it's about, essentially, is propagating changes through our app. That is what streams do. And if you think about it, that's a very relevant mental model for web apps, because a web app has no reason to do anything unless some change, some event has happened. And then once an event has happened, our job as developers is to make sure whoever needs to know about it knows, and that they react accordingly. And what FRP does is it allows us to write code that accurately describes this process without layering abstractions and patterns on top of that. And I think this ability of code to accurately describe what it does is the opposite of over-engineering. And I think that is why it is so worthwhile to get into this paradigm, get over that initial hump, and see what we can learn and what we can bring back to our everyday work. That's it for me. Thank you guys so much. There is a link to the repo here. You guys feel free to check it out. And then if you have any questions, feel free to come talk to me. And you can also DM me on Twitter. Thank you.